Now we're going to use the same equations. I have f of x equals x squared plus 2, and g of x is the square root of 3 minus x. But now we're going to have to define this function differently. We're going to have g composed with f of x and then state the domain. So this means I'm going to take g of f of x. So the first thing I need to do is determine the domain of our input function. Well, the domain of our input function is negative infinity to positive infinity, right? Because this is a parabola. Now I need to find the domain of the composite function. So I've got the square root of 3 minus x squared plus 2. So g of f of x is the square root of 3 minus x squared minus 2. So I have the square root of 3 minus x squared. Nope, sorry, 1 minus x squared. 3 minus 2 is 1. So I have the square root of 1 minus x squared. So when is this going to equal 0? So we can figure out our domain. So I have 0 is the square root of 1 minus x squared, square both sides. 0 is 1 minus x squared. I subtract 1 from both sides. Negative 1 is negative x squared. 1 is x squared. Square root of both sides. X equals plus or minus 1. So let me show you what this graph looks like, and you can check this in Desmos. So my x can only take on values. If I have this composite function is the square root of 1 minus x squared. Remember, we can only graph positive numbers. So if like x was 2, well, 1 minus the square root of 4, that'd be negative 4, okay. What if x was negative 2? Well, 1 minus the square root of negative 2 squared, which is 1 minus 4, which would again be a negative number. So my graph looks like this, and you can check this in Desmos if you want, but this is what the graph of our function looks like, kind of like a semicircle. So although our domain of our input function, f of x, was all real numbers, in this case, our domain of our composite function is all values of x such that negative 1 is less than or equal to x, which is less than or equal to 1. We can only take on values between negative 1 and positive 1.